So this is the end of our chapter 4 practice test. There's not too much left. Um, the first problem gives me a function or a description of a function, wants me to create a function from it using x squared as a seed function, and then describe how this new function's graph compares to that of the graph of x squared. And that's something we've done quite a bit already, and we're going to continue to do so. Don't forget this after this chapter. So I'm using the x squared function. If there's a parentheses, that if the parentheses has more than just an x, you need a parentheses. And what's in the parentheses in the original problem will go in the parentheses in your answer. And the plus 2, since it's not in a parentheses, are just going to go after the x minus 1 quantity squared. In terms of shifting, minuses inside parentheses move a graph right. Pluses after the function move the graph up. So this graph is going to be moved right 1 and up 2. I'm going to make my table down here, and I'm going to use my calculator to do my table. Since this is written in standard form, I'm going to change the sign of the -1, put it in the middle of my x column, and go smaller and bigger. Pull out some calculator, hit my y equals, clear out anything that's in there. And this is parentheses x minus 1 squared plus 2, second table. Next to -1, I see 6. Next to 0, I see 3, and then 2, 3, and 6. When I'm graphing parabolas, I always make it so my vertex is in the center. And you can tell if your table is decent if the y's repeat. If the y's don't repeat, then your table is probably not such a great table. Just made my program graph the function. Next thing is to find the domain in the range, which you can do without just by inspection. But if you wanted to, you could extend the graph in this direction, and this direction is left in the x direction, which will make the start of my domain x equal -infinity, and extend the graph this way. Since it's going right in terms of the x direction, that's going to make the end of my domain +infinity. All the graphs that we did in this chapter of the parabolas, they all have the same domain of negative to +infinity. For the range, I read from bottom to top. This graph has a physical bottom. So the bottom gives me the start of my range, and ranges are y's. So the start of the range for this graph would be y equal to 2. And the graph doesn't have a top. Both of these left and right extensions lead to the end of my range. And both of those go to the top of the y-axis in terms of the up direction, and that's y equal infinity. Didn't close off my parentheses there, which I should have. Domains and ranges, the style of brackets is important. And infinities always get round brackets. For my range, the leading 2 is going to get a square bracket because it's from a marked point on the graph. And then the ending infinity will get a round bracket. The next question, the increasing and decreasing, those are all purely round brackets. To separate this into pieces or halves, to do my increasing and decreasing, I need the graph to the left of the vertex and the portion of the graph to the right of the vertex. The portion of the graph to the left of the vertex is its decreasing side, because as I trace along the graph, my marker is getting lower as it moves from left to right. And then once I get beyond the vertex, if I'm tracing, my marker starts getting higher as I'm tracing. To the right of the vertex is the increasing side of this graph. And when I'm describing the intervals for increasing and decreasing, it's only x's and only round parentheses. So for this part D, you should only have x values. You should only have round parentheses. These don't get square brackets. And in terms of trying to describe this half, the decreasing half, it goes from the far left edge of the x-axis, which has an x-coordinate of negative infinity, to the minimum point, which has an x-coordinate of 1. The other half, where it's increasing, starts at the x-coordinate of the minimum point, which is 1, and it goes all the way to the far right edge of the x-axis, which has an x-coordinate of infinity. So when I go to write my answer, I can say it's increasing in the interval 1 to infinity. And if I don't want to write the word decreasing, I could just put an arrow that points down instead of writing the word decreasing. And then after that arrow, say it's the interval from negative infinity to 1. E and F in parabolas, parabolas don't have both a maximum and a minimum point. If the vertex is located at the top of the parabola, it's a maximum point. If the vertex is located at the bottom of the parabola, it's a minimum point. Part E says state if the function has a local maximum point. I'm just going to say it has no local maximum point, or there is no local maximum point, or some sort of negative word there. I don't exactly know what the best English word would be, but there's nothing to answer here because there isn't a maximum point. F does have a local minimum point. The way it's worded, it almost sounds like it doesn't want the point. I should probably improve the wording, but I'll leave it for now. The local minimum point is the vertex of 1, 2. And then it says if it has a local minimum point, state the local minimum value. And then that's just the y-coordinate of the vertex. My local minimum value is going to be y equal to 2. And usually we tack on some words after it, adding in the x. So I'm going to say which occurs when x equals to 1. 7 is the problem where we need to use completing the square to write the parabola in a nicer order. And I'm going to do 7a down here. So use completing the square to rewrite the problem. First I'm going to group the x's and put them in the parentheses. So I'm going to rewrite this problem as f of x equals to parentheses 2x squared plus 8x plus 5. Then I'm going to add c and subtract. Normally I would say, whoops, then I'm going to pull out my common factor. Got ahead of myself. If there is a number in front of the x squared, that number is set up to be a common factor. And so inside this parentheses, I need to factor out the greatest common factor of 2 first before I get involved with my c's. Now I can get into the c part of this. I'm going to add c inside the parentheses, but I'm going to subtract 2c outside the parentheses. The reason is when I go into this problem and I add a c inside the parentheses, if I was to clear the parentheses, this parentheses that I have written here, I would get 2x squared going 2 times x squared plus 8x, and then I'd get plus 2c. And I need to keep this problem equal to the original problem. If I simultaneously add and subtract 2c, this would reduce to 2x squared plus 8x plus 5. So if you put a number in front of the parentheses, you need to subtract c times that number. And now I'm going to change the c to a number. So c is always the number in front of the x to the first power term, first divided by 2 and then squared. So c is 4 divided by 2, which is 2, squared, which is 4. Got a shorthand room there. That's minus 5 times 4. I don't think I can get the right parentheses in. And now I'm going to quickly factor that parentheses. So this I'm going to factor. And these are going to combine or simplify. And how do I do the quickly factoring? Super easy. I write one parenthesis with an exponent of 2. The x squared that leads off the parentheses is going to lead off my factoring. And what goes after the x squared is the number in the c computation that has the exponent of 2 right before I got the actual value of c. And that's a positive 2. This set of numbers here, 5 minus 2 times 4, is negative 3. I would consider this good enough for part A. It's not purely standard form. Standard form of a parabola technically has a minus inside of parentheses. But I'll live with it. I'm going to describe the transformation, then I'll go write it in purely standard form. If I wanted to compare this function's graph to the graph of x squared, the 2 out in front would stretch the function or make the graph narrower. The plus 2 inside of parentheses would move the graph 2 units to the left, and the minus 3 would shift the graph down 3 units. That's everything I need for question 7. I could, if I want to, change this plus to a double negative, and I could say that this is purely standard form, but I didn't really do much with purely standard form in the section because I can work around it real nicely. But either of these would be acceptable answers for 7a. 2 more word problems left, and that's the whole review. I sketched a graph for problem 8. I can't get the whole graph on the screen, but I will in a second. So 8 talks about, should say a ball. A ball is fired vertically into the air and it will be at a height of h feet. So this h is the height of the ball after t seconds. These t stands for the time in seconds. And the question is, how long does it take to hit the ball? What's its maximum height? When does it reach its maximum height? And what is its maximum height? So I sketched a graph so you can see the flight of the ball, and I marked the key points. The first key point I marked was the point 0, 0. The x coordinate is the time in seconds. So that 0 there means at 0 seconds. And that 0 means the height. Is 0 feet. This point 10, 0 says at 10 seconds, the height is 0 feet. And that's probably the point that I need for how long will it take to hit the ground, because it hit the ground level is 0 feet, and that happens at 10 seconds. The other point that I marked, the point 5, 400, stands for 5 seconds and 400 feet. And you can see by the path of the flight that there is where the maximum height is. The maximum height for this ball is 400 feet and it occurs at 5 seconds. So I could answer all of these questions if I had a graph available, but it's not going to be available on the test. But how long does it take to hit the ground? 10 seconds. When does the ball reach its maximum height? 5 seconds. I made a box there and I couldn't fit seconds in there, so I just abbreviated it. And what is the maximum height? 400 feet. These are the answers. Now I'm just going to get algebra to show those answers because you're not going to have the graph at your fingertips. How do I get the answer to part A? Simply take the function, set it equal to 0, which is the height of the ground. I'm going to solve this by factoring. 16 goes into negative 16 goes into 16, 16 goes into 160. I'm going to factor out a negative 16 to get closer to my answer. And both of the terms in this problem has a t. I'm going to also factor out a t. So to get the answer of 10 seconds, I'm going to pull out a common factor of negative 16t. My first entry in my parentheses is just going to be positive t. I factored out the negative 16, so I'm just left with a 1 essentially. And when I had started with a t squared and I factored out a t, I'm going to be left with a single t. After the plus sign, I'm going to change its sign because I factored out a negative. And the number that I'm going to get is 10, because if I factor out a 16, I need to divide by 16. Technically, I need to divide by negative 16. And 160 divided by negative 16 is going to give me negative 10. I took that t away, so the ending of the factoring here just gives me negative 16t times t minus 10. Still have the equal to 0. Now that I have it factored, I separate each one separately equal to 0. The factor of negative 16t, I divide by negative 16 and get t equal to 0. That's the, it starts on the ground. The t minus 10, when I set it equal to 0 and add 10 to each side, this gives me the 10 seconds it takes to actually hit the ground. So the two numbers show up in the graph of the initial height and the ending height. I'm worried about the ending height, not the initial height. For part B, when it reaches its maximum height is the x-coordinate of the vertex. I get the x-coordinate of the vertex by using the negative b over 2a formula. And in this problem, a is negative 16 and b is positive 160. So the time that it reaches its maximum height is negative from the formula, and then b, which is 160, and then in the denominator, 2 from the formula, and then a, which is negative 16. This is going to give me negative 160 over negative 32. And I suppose that comes out to 5 because I know what the answer is ahead of time. For part C, to get the maximum height of the ball, I'm just going to take the 5 that I just computed and plug it in to each of the t's in the original problem. And that should give me 400. So if I do negative 16 times 5 squared plus 160 times 5, it'll give me the 400 feet. So that's everything for 8. We just have one problem left to do. And this has to be just a duplicate of a question from the chapter with just numbers changed. This is kind of usually how I create word problems for the test. Similarly, the last problem, if you looked into section 4.4, I'm sure you would find that problem with just different numbers. So this shouldn't be new. So a chain store manager has been told by the main office that the daily profit P, so this side represents the profit, it's actually the daily profit. The daily profit P is related to the number of clerks working that day. So this is the number of employees. I guess specifically clerks working on that day. And then I sketched a graph of this. I didn't label the intercepts because it wasn't necessary, but each point on this graph is the x coordinate is the number of clerks. The y coordinate is the daily profit. And then because the vertex is a maximum point, this is where I'm going to be searching for. You can see that this is kind of the graph of the profit relative to the number of clerks, and you can see that there the highest profit works here. So my answer is 5 clerks are going to maximize profit, and my daily profit will be $625. I'm going to get this answer just like I did the last 2 parts of question 8. The number of clerks to maximize the profit is the x coordinate of the vertex, and I'm just going to use the negative b over 2a formula to get that, where a is the number in front of the squared term, which is negative 25. B is the number in front of the first power term, which is 250. So negative b is going to be negative 250. 2 times a is going to be 2 times negative 25. And this comes out to negative 250 over negative 50. And I could do that in my head. That reduces to 5. So I'm just going to write an answer for part A of number 9. And just say 5 clerks will maximize profit. And then what is the maximum profit? Well, it's $625. How do I get it? I'm just going to put a 25. I'm going to put a 5 into the x in my profit function and do negative 25 times 5 squared plus 250 times 5. I don't know why I just put this extra parentheses. It's going to give me an error. And that's the $625. So between the 2 parts, this is everything. I never ever sneak anything on the test that isn't like something that made its way onto this practice test. So if there's problems in the chapter that, that didn't make it onto this practice test, they're not going to make it onto the test. If you just perfect this practice test, you should be in a good place for the test.